Right, for a cosine function, it's quite similar to sine function, but it has its differences as well. So let's have a look. Andrew next considers the horizontal displacement d of the light on the Ferris wheel. So in the diagram, cos theta equals d over 10, so the radius is d, so d equals 10 cos theta. So we can write the horizontal displacement of the light, d, as a function of theta, going around the circle, or alternatively, we can write the d as a function of time t. That's ongoing as well, so that becomes a period, and then it keeps repeating itself over the same period, etc. So Ferris wheel takes 100 seconds for a full revolution, so as you can see, 100 seconds for a full revolution, the maximum point to the maximum point. The graph of horizontal displacement against the time is shown along. The amplitude is 10 meters. How do we know that? Well, it's from the halfway line to the maximum point, or halfway line to the minimum point. And the period, which is the duration of that one cycle, which is 100 seconds. So that's how you read a graph. So basic cosine curve characteristics, we obviously know that the amplitude is 1, so that's not going to be different from the sine wave. We know, our standard's going to be 0 to 2 pi. So it starts from a maximum, goes all the way down to the minimum, and then goes back up to the maximum. So it's a bit of a, it's showing the different part of the graph rather than starting from here like a sine graph. So some of the things we know is cos x has a relationship of sine x plus 2 x plus pi over 2. So what that means is this graph, the dotted line, is our regular sine wave that we have been used to. However, our cos graph, it goes pi over 2 that way. So we have already learned some transformation ideas. So if we transform, our number plus pi over 2, it becomes our cosine graph. So that's pretty awesome to see. General cosine function looks exactly the same as the sine function, just cos and sine is alternated. So you've got, something, I can't exactly remember on top of my head. You should be able to tell me because you have your notes in front of me. In front of you, A should have a different effect, B should have a different effect, C should have, I think, translation effect, D was a translation effect as well. So A and B must have been the dilations. So it has the same exact effect. So looking at this on the same set of axes, we're going to try to graph these. So again, I'm going to draw our standard one, the cos graph, so we can keep that in reference point. So we have pi over 2, pi, 3 pi over 2, and then 2 pi. Our maximum and minimum's 1. And then I start at a maximum. Alright, and then, oh, sorry, I didn't see this range, so I actually have to draw a little bit further. Do I have space? Nope, I'm going to have to redraw this. So we actually want minus 2 pi to 2 pi. I just didn't see that. Alright, so either pi is either minus pi, minus 2 pi, 2 pi. Alright, so I start over here, and then let's just double check. Our regular cosine graph has a minimum at pi and then goes back up at 2 pi, so that's what we're going to draw. I'm going to draw the first one, and then I'll just copy it over to the left-hand side. So the minimum's here, and the maximum's back up here, so it's 1, negative 1. So it looks something like this. And then if I extend it further, minimum, maximum. There we go. So that is y equals cos x. And now I have to do pi minus 3, minus pi over 3. So let's just go back and quickly have a look at what the different variables meant. So it was inside the bracket. It was a horizontal translation. So let's go back and read some of those notes. Alright, so it was horizontal translation. So minus C becomes a C units. Okay, good to know. So minus pi over 3, so that becomes your C. So horizontal translation of plus pi over 3, even though it's a minus because it's the opposite. So that means I have to go that way, pi over 3. So it just means I have to draw another graph that is pretty close because, you know, these are pi over 2s. So it's going to be less than that, you know, this amount because that's pi over 2. Pi over 3 is smaller than pi over 2 if you use your calculator to figure it out. I'm going to move it maybe this much, just approximately, and then move all the dots like so, and then we can just write plus pi over 3. I'm just going to draw like a little point to kind of guide me. So I'll go down, maximum, down, maximum, and write my equation. And I'm going to draw my little plus pi over 3, plus pi over 3 to clearly indicate that it, you know, was a plus pi over 3. We obviously just can't draw the most accurate graph of this because we don't have enough scales to be able to show that. But that's it. Without using technology, we're going to sketch the graph of y equals 3 cos 2x. Make sure you write the heading example 6 for this one. So we're going to have 0 to 2 pi. Hopefully I got the range right for the other one. Yep, I did. We checked that. So I'm going to draw the regular one, the cosine function for 0 to 2 pi first. Okay. There might not be enough space like this. Alright, so that's 2 pi. My original function has maximum 1 amplitudes, and then minimum, maximum, minimum, and it goes through these points, so it goes something like that. Now I need to figure out what happens next. So y equals 3 cos x. Let's see what that 3 does first of all. If I go back to my notes, hopefully you've got yours right in front of you. 3 was the amplitude, the in front of the, so that was the outside was affects the amplitude of the graph. The mod A is the amplitude. So graph is a vertical dilation, so it goes, it's going to get stretched out bigger. So we're going to give that one a go. You know, our mod of 3 is just positive 3, so that just means my amplitude becomes 3, so hopefully I just have enough space to draw that. Max, minimum, and maximum. There we go. So I'm going to try my best to draw my wave. Let's just say that touched, that will do. So that is my y equals 3 cos x, but I've got to do, not done yet, y equals 3 cos 2x. Now what happens if there's a 2 inside of that cos function? Let's go have a look and see what effect it has. So inside means horizontal dilation, so you know we're grabbing it by each side and either squishing it together towards each other or pulling it out. Scale factor of 1 over b, b is the number in the period, changes as well, 2 pi over b. Let's see if I can remember that. So scale factor is going to be 1 over b, which is 1 over 2 in our case, so it's going to half. My period is going to be 2 pi over b, so it's going to be pi. So that means my one oscillation finishes in pi. So I'm going to have to draw 2 lots of this graph. I'll draw it with a purple one. I'll change the red one. No, already have a run on. A blue one. So I'm going to start here, then I'm going to basically half everything. So my halfway point is over here, my minimum point is over here, and then it should stop back over here, and then I'm just going to repeat that because again it's an oscillation. So I should be having something like this. Let's give it a go. Alright, maximum. Oh, that's too far. So I should go in here and here. Down, and then up, and then down to my minimum, and then up to my maximum. Awesome. So that one is 3 cos 2x. Alright, and that's it. So just do it step by step. You should be able to do these questions now. Give it a go and make sure you check your solutions.